What's up, guys? This is Vishnu.
It's Joey.
And this is part A and B of Lab 6. So the only difference between A and B is the input voltage. In part A, we're using a 15 volt source, which we use using the laboratory power supply. But for part B, we're using our Digilant to power it with 5 volts, and we're using varied measurements of the potentiometer. And we're calculating VC and VE, and we're trying to manipulate the value we're getting for the IC current. And we're doing this by changing the values of R1 and R2. And as you can see, we have our data points right here.
Part A is highlighted.
As you can see with part A, we consistently see an approximate IC value of 5 milliamps. And for part B, we consistently see a value, at least at the beginning, of approximately 1.7 milliamps. And another thing to note is how VC never goes below VE. So yeah, that's part A and B. Okay, so this is our part C. And as we can see, we have a power supply of 5 volts, and we have a power supply of -2 volts. And our resistor values are 2K. We made that out of two 1K resistors and a 1K resistor as well. So basically, we noticed that the gain was a ratio of RC over RE, and we can see that here. So we have an input sine wave 0.5 volts peak to peak, and we have that multiplied by a factor of RC over RE to create our gain. And as you can see, our gain is found using the cursor. Yeah, this is our network sweep. Some important things to note about these graphs are that we have to assume DC biasing, which is why we put the DC value equal to 0. And we notice that it's out of phase, which is why gain is negative. So that is because the value for gain is equal to negative RC over RE. And this is our graph of the emitter voltage over our input voltage. And again, this is a factor of using DC offsetting, and we can see that it is in phase. Alright, thank you.